In this video, we're going to talk about how do we use all the laws of exponents and everything that we learned about simplifying monomials in order to do more application problems. So a lot of these problems are more of the problems you would see on SAT, PSAT, also just more like application of these. So again, we'll just kind of start with the first problem. Okay, so here we're trying to find what is the value of a that's going to make this part equal to 25x to the 14th. So before we start, I just suggest, well, let's use what we know about simplifying a monomial to simplify this side right here. So the first thing that we can do is, the numerator and the denominator are as simplified as possible, but we can definitely simplify the inside of these parentheses by dividing, right? So 10 divided by 2 is just 5. And then x to the a divided by x to the third, they have the same base. So I can definitely go ahead and simplify them, but this is not a number. So if you remember your quotient law, right? If you're dividing, you're supposed to subtract the exponent. So we're just going to go ahead and do x and a minus 3. We're going to put those parentheses, and again, it's still being squared. Then we can go ahead and expand this. So this is just 5x a minus 3 times 5x a minus 3 is equal to, again, needs to equal 25x to the 14th. And 5 times 5 is 25. Good, so we have the 25. And then x a minus 3 times a minus 3. Again, what would we do to these exponents? If it was like a 2 and a 3, we would add them. So that's the same thing we're going to do here. Let's go ahead and add our exponents. So a plus a is just 2a. And negative 3 plus negative 3 is negative 6. We could have just done that by distributing this 2 using power to a power. But again, unless you really understand where it comes from, I suggest you just expand it every single time to kind of make sure that you're not making this 5 into a 10 instead of a 25. Okay, so now here we go. So we have the 25, good. So our coefficients are equal. Now all I have to do is I have that my x's are both sides are good. I just basically need to make sure that my exponents are equal. So basically this 2a minus 6 has to equal 14. So we can set up that equation, and that is a very easy linear equation that we have done many times in the past. So let's go ahead and solve for a. So we're going to add 6 to both sides. And so you're going to have 2a is equal to 20. And divide this by 2, and you get that a is equal to 10. So if a is 10, then those sides are going to be equal. And again, you can always plug it in, right? If a was 10, so if this was the number 10 instead of a, then when I would have simplified this, this would have become 5x, and then 10 minus 3 is 7. And then if I squared this, 5 times 5 is 25, and x to the 7th times x to the 7th is x to the 14th. So it works. Okay, so now let's get on to a slightly more challenging problem. So before we get to this is the problem that we're going to do. I want you guys to keep in mind that in order to use laws of exponents, you need to have the same base. So if you don't have the same base, which is what's going to happen in the next problem, we're going to try to see, can we make something into the same base? So for example, 2, 4, 8, and 16 all can be made into the same base of 2. So 2 is just 2 to the first. 4 is just 2 to the second. 8 is 2 to the third, because 2 times 2 times 2 is 8. And then 16 is 2 to the fourth, because, again, if you multiply 2 by itself 4 times, you're going to get 16. So very similarly, 3 is just 3 to the first. 9 is going to be 3 to the second. 27 is going to be 3 to the third. 81 is going to be 3 to the fourth. All right, and then now let's go ahead and do 4 and 5. Now, usually with 4 and 5, because they get really big, we don't really go beyond the third power. So 4 is just 4 to the first, 16 is 4 to the second, and 64 is going to be 4 to the third. Just going to make this 2 a little bit more apparent. All right, now for 5, we have 5 is 5 to the first, 25 is 5 to the second, and then 125 is going to be 5 to the third. Now notice that you can make 1 in a base of all of these. So remember, 1 is going to be equal to 2 to what power? To the 0 power. 1 is going to equal 3 to the 0 power. 1 is going to equal 4 to the 0 power. And 1 can also be equal to 5 to the 0 power. So you can always make 1 regardless of your base. You just have to put that 0 power there, because remember we talked about anything to the 0 power is just the number 1. So keep that in mind for the next problem as well, eventually. Okay, so we have this. We need to make this the number 3. So first of all, 3 needs to have an exponent, so this is just 3 to the first power. And then here, this 3, 4 to the x power already has the same base here. But can we change the 27 to have a base of 3 so that we can go ahead and use our laws of exponents? Let you think about that and look at that chart that you wrote down. Well, yes, you can make 27 into 3 to the third. Again, this should have been a 3. I know it looks a little small there. Okay, so on the top, we're going to have 3, 4 to the x. It's on my numerator. And on my denominator, we're going to have 3 to the third. But it's to the y power, right? So just make sure. Again, we're just doing kind of like substitution. So instead of writing 27, I'm writing 3 to the third. And then on this side, we have 3 to the first. Now, if you remember your power to a power rule, right? Basically, what's going to happen here is that this power gets to distribute, and then you're just basically multiplying 3 times y. So I can go ahead and simplify this further to 3 to the 3y power, and equals 3 to the first. Okay, I can simplify this side even more because now they have the same base, and I'm dividing, and I can use my law of quotients, right? My quotient law that says that I can go ahead and subtract my exponents if I'm dividing. So I can condense this to 3 to the 4x minus 3y power, and I need to get this to equal to 3 to the first. Okay, they both have the same base, so in order for them to be equal, they need to have the same exponents. So 4x minus 3y has to equal 1. And did I answer the question? Let's go back. What is the value of 4x minus 3y? It's 1. We're done. That's it. Okay, so again, this is more of a PSAT, SAT question that I wanted you guys to get exposed to. So now let's do another, this is more application. So scientific notation is used all over the place, especially in science, right? So we need to know how to use it. Okay, so first of all, in scientific notation, 3 and 5 would be considered, right? They're my coefficients. Now 10 to the 5 and 10 to the negative 3 are my exponents with a base of 10. And basically, this is telling you how many zeros you have. So in this case, right, I'd have, if I have 10 to the 5th power, right, how many zeros would I have? Yeah, 5. If I have negative 3, then you have 3, but we have that decimal, right? So I just want you guys to keep that in mind, that that's where we would use this. Now, 3 and 5, we would treat it just like, right, they're going to be my coefficients. So 3 times 5 is 15. And then times 10, we have to figure out what my exponent will be. Well, if I'm multiplying, then I would just add up together my exponents. So 5 minus 3, which is 2. Okay, so now let's go on to the next problem. And so another way you would see the application of monomials is just by when you're finding area of a rectangle. So I have that these are my two sides, 3x squared and 5x squared. So if I'm excuse me, if I'm trying to find the area, all I have to do is go ahead and multiply my length and my width. So you're going to do 3x squared times 5x to the third. And at this point, this should be pretty easy. So 3 times 5 is 15, and x squared times x to the third, well, I'm multiplying x by itself 5 times. If I use my product rule, I'd add those exponents, and that's it. This is my area. Okay, so that is the end of this video, and I hope that you found this helpful in terms of application.